Welcome back everyone. In today's lesson, we are exploring another beautiful circle theorem that students often overlook, but it's extremely powerful in solving geometric questions. It is the theorem that says equal chords in a circle are equidistant from the center, and we are going to look at what the theorem means, how the distance from the center is measured, why the theorem is true, how to apply it to exam questions, and a fully solved example. Let's begin. The theorem says in a circle, equal chords are equidistant from the center, and conversely, chords that are equidistant from the center are equal in length. This means two important things. Let us consider this diagram for more explanation. If two chords have the same length, for example, in this diagram, our chord AB is equal to chord CD. Then the perpendicular distance from the center to each chord will also be the same. So the perpendicular distance OX and OY will be equal to one another. If two chords are the same distance from the center, what we are saying is that OX is equal to OY, then they must be equal in length. That means chord AB and chord CD must be equal to one another. What is the distance from the center? It is the length of the perpendicular line drawn from the center of the circle to the chord. In this diagram, O is the center and AB is a chord. Then the distance is the length of OX, where OX is perpendicular to AB. Let us prove the theorem and let us consider the diagram. The center of the circle is O, and it is given to us that chord AB is equal to chord CD, and also OX is perpendicular to AB, and also OY is perpendicular to CD. Let us join OA together. And also, let us join OC together. In a circle, a perpendicular from the center to a chord bisects the chord. So we can say AX equal to XB, and also CY equal to YD. Consider triangle OXA and triangle OYC. OA equal to OC because they are radius of the same circle. we can also say AX equal to CY. Because the chords are equal and bisected into equal halves, it is also given to us that OX and OY are perpendicular, so the triangles are right angle. Using right angle hypotenuse side congruency rule, triangle OXA is congruent to triangle OYC. Therefore, OX equal to OY, because corresponding parts of congruent triangles are equal. That is the proof. Let us consider this example. In a circle with center O, chord AB is 12 cm long and the perpendicular distance from O to AB is 5 cm. Chord CD is also 12 cm long. Find the perpendicular distance from O to chord CD. Let us use diagram to express this given question. This is our diagram from the given question, and it is given to us in the question that our chord AB is 12 cm, our chord CD is 12 cm, and the perpendicular distance from O to chord AB is 5 cm. Since chord AB and CD are equal, so by our theorem, equal chords are equidistant from the center. Therefore, we can say from O to our chord CD is equal to from O to our chord AB. So our distance from O to CD is equal to from O to AB, and from O to AB is 5 cm. So our distance from O to CD equal to 5 cm. And that wraps up today's lesson on the theorem. Equal chords are equidistant from the center. These theorems makes solving many circle geometry problems much easier once you understand how perpendicular distances relate to chord length. If you enjoyed this explanation, don't forget to like the video, drop any questions in the comments, subscribe for more geometry lessons made simple. Thank you.